everybody. Today I'm going to be talking to you about our Alloy Lab. We're going to be debriefing the lab to help you write your lab report. This is going to be a relatively brief debrief, so hopefully that helps with the actual lab report you're writing. Alright, so number one on the analysis and conclusions, 1A, has you compare the three coins. Alright, so the one that we didn't treat at all, the one that was heated in zinc chloride solution only, and then the one that was heated in the zinc chloride solution, and then heated in the Bunsen burner flame. It says, do the two treated coins now look like other metals? If so, which ones? Okay, so the first thing you have to do is you have to make physical observations of all three coins, because it asks you to compare the three. So what are similarities and what are differences in the physical observations you made in your data table between the three pennies, okay? And then you can talk about, do they look like other metals? This is subjective. Do you think any of them look like metals, perhaps elements that we'd find on the periodic table? All right, so you can go through and you can kind of figure out on your own what they look like. Part B says to draw particle pictures for the two pennies that we treated. So the one that we treated in zinc chloride and the one that we treated in the zinc chloride solution and then in the flame. Okay, so what we want to do here is we want to show what's happening with the particles. And it says to distinguish between the copper and the zinc atoms. Okay, so you can do this a number of ways. You can have copper be perhaps triangle, and zinc could be, we could have zinc be circles, right? You could do two circles and have one of them colored in, whatever you want. All right, so we need to figure out, I'm going to show you what's going on with the zinc chloride one. You guys will be responsible for fixing zinc chloride and then treating the flame. You have to figure that out on your own. You have to include both of them in your lab write-up, okay? So what we have here is our penny, okay? Now we figured out that the pennies that we're working with, right, we have mostly copper. I'm putting triangles here because that's what I said copper was in my key, okay? So everything inside here is triangles, all right? And what we did in this lab is we coated the penny with zinc, okay? So my zinc is the circles. Maybe I'll make these colored in circles, okay? So I'm going to draw colored in circles all the way around. I really should not have done colored in circles because it's taking me longer. Okay, and really they should be a little bit closer to each other. Fill in the gaps. All right, so what we have here is a penny that is copper, and it is coated with zinc. Okay, what we did then is we heated this in a flame. Okay, you might in parentheses put here what phase change is happening. Okay, is it freezing or melting? Is it boiling? Is it condensing? Okay, so you might put in parentheses what phase change is actually going on here. And then you get to draw the particle picture for the penny treated in zinc chloride and the flame. Okay. Number 2 says, what was the purpose of the post-1982 penny? I'm going to let you guys figure that one out on your own. You can talk to some peers, but remember that we talked about different variables that are present in experiments, all right? So what kind of variable might this post-1982 penny have been acting as, and why? What was the purpose of actually using it? All right, now we're going to move on to number 3. All right, number 3 asks you to identify the class of matter of the penny before treating and heating, and then after treating and heating. So before we did anything to it, and then after, so this after picture. Now, just a reminder, our classes of matter can either be a pure substance or a mixture. If it's a pure substance, it's an element, which we would find on the periodic table, or compound, which is a chemical combination of those elements, okay, 2 or more elements. Or it can be a mixture, which is a physical combination of different substances, okay? If it's a mixture, it can be homogeneous or heterogeneous. And remember, homogeneous, the homo means more the same throughout, looks the same throughout, and heterogeneous looks different throughout. homogeneous can either be a solution, which most homogeneous mixtures are, or at the micro level, or at the macro level, sorry, it can be a colloid, okay? At the micro level, what's really going on with our colloids, remember those, the milk, the fog, the air, or the steam, or smoke, sorry, that we talked about. At the micro level, they're actually heterogeneous. They're not the same throughout. Our heterogeneous mixtures can also be suspensions, which settle out if left to sit, or they can be any kind of other solid. Okay, so you need to figure out what's going on with that penny. What is it before we did anything to it? And then after we actually treated it in the flame, what has it become? Okay, if anything different. You might take notice of what phase change you say is going on there, okay, for this question. All right, number 4. Was a precious metal made in this lab? And what properties can be determined to figure out if it was or not, okay? So this is one of those that you are going to take the time to just look up. What is a precious metal, okay? There's only a few of them, so you'll be able to identify if you made one of those few precious metals. And then what are the properties that can help you determine, okay? We've talked about one of these properties. Our last lab, in fact, was density. So how might that be something that can help us figure out if a precious metal was actually made? Okay, think about what you know about density, and you actually have to explain that in this question. Okay. Number 5 is again one of those that I'm going to let you look up on your own, okay, because it's asking you to define an alloy, which is easy enough to look up. To identify the alloy, which is again easy enough to look up. What alloy do we make with copper and zinc, okay? And what are the uses of this alloy? All very easy to look up. The last question asks you to write a claim, evidence, and reasoning paragraph, okay, about what type of change, a physical or chemical, occurred with the penny, okay? So you're going to have to figure that out. What's the difference between a chemical and a physical change, right? Go back to Unit 1 and look at the definitions. I want you guys really pulling in content from our previous units as much as possible, density, physical and chemical changes. And then you have to write your CER. Make sure that you are going in the order of claim, and then evidence, and then reasoning. Your claim should just be a claim. The claim should literally be the change that occurred was a physical change. Or when the penny was treated with zinc chloride and then treated in the flame, a physical change occurred. Or a chemical change occurred, okay? Name one of them, and that's your claim, okay? The evidence, make sure it comes from your data table, okay? It has to be from those observations that you made in the data table. And then your reasoning comes at the very end. How does this evidence justify this claim, okay? All right, that's it for our Alloy Lab debrief. I know there's quite a bit that you have to do on your own, which is fine. It's a lot of looking things up and looking back to units 1 and 2, okay? That's it. See you guys next class.